we basically build power plants that can generate zero emission electricity and can store energy, grid scale energy for long duration at about 1/10 the price of today's most advanced lithium ion batteries. So that is what we do. Very quick, can I just get to the problem before that? So you've probably seen the video, the UN video just 2-3 days back, where the small girl talks to the world leaders saying, how dare you put the whole climate issue on our heads. I should be in school living my life, but you're doing this. So that is a very good idea, good thing to do. But the problem is, what do you do otherwise? Sure, you can shut down all the power plants, but what do you do? How do you get electricity then? So we've had a lot of wind, solar. Prime Minister Modi is full on wind and solar. So that is a good thing. Only that they're not really replacing the grid, the black part of the grid. They're replacing peaker plants, which come online for a bit. They're not the base load generators. The base load generators are gas-fired and coal-fired plants. Despite a lot of solar and wind coming on board, the investment in coal and gas has also increased. So it's not decreasing. What is decreasing is gas turbine power plants. They're very expensive. They always have been expensive. And that is the only thing being replaced. If we need solar and wind to be on the grid and replace coal, you need a lot of storage. Basically, Bill Gates quote, every single battery on earth, if you combine all of them, your laptop battery, phone battery, whatever it is, that cannot store enough energy to last 10 minutes for all of the Earth's current energy needs. So we are in a very bad position. Also, it is very expensive. So that is the key problem we are trying to solve. We want to give an option to enable solar and wind to come online and do what they promised about 10 years back. So how do we do it? Is basically we build something very similar to typical thermal power plants. Just in case some of us are not engineers, I'll just describe a Rankine cycle very quickly, which is typically used in all thermal power plants, nuclear, coal, gas, whatever it may be. Basically, you take water, you heat it to about 300 degrees Celsius, very hot, superheated, supersaturated steam. It contains a lot of energy. You use that energy in a turbine, generate electricity. The problem is, what do you do with that steam? That has expanded 1,600 times its actual volume. So either you let it in the atmosphere, which is a bad idea because you need very pure demineralized water continuously, expensive and waste of time. So basically we send it to a condenser. It removes the heat. 42% of the energy you've put in has just been thrown out into the atmosphere. And then it liquefies and then you repeat the cycle. So you lose 42% to about 50% for no reason whatsoever. What we do is we use a proprietary working fluid that we've built. We run it the same way. Instead of burning fuel, we use thermal sources. Can be solar thermal, can be waste heat from industries like sugar plant, cement plant, refineries, iron mills, whatever it may be. It expands to almost 1:900 times, which is a very high expansion ratio. The best jet engine today has an expansion ratio of 1:44. So you have a lot of efficiency boost there. Runs a turbine, generates electricity. We have the same problem. What do you do with that gas? Instead of passing it through a condenser and wasting so much energy, we use catalysts, electrocatalysts and chemical processes, which effectively absorbs the working fluid at 1:10,000 ratio, creating a sort of vacuum, increasing the efficiency of a turbine. And this basically, if you provide a little bit of energy, it changes its property, the catalyst. So it's called a pressure swing adsorption cycle, in which case it starts desorbing that working fluid again at very high temperature, very high pressure and a little bit higher temperature. So all you need is a small radiator sort of a system. You don't need those huge cooling towers, and it reliquefies and the cycle goes all over again. The thing is, the catalysts and the chemical processes are batch processes in which you can control the energy rates, the reaction rates, and that acts as our grid scales energy storage system. With electrolytes, they discharge over a period of time. But if you put two reactants together. Unless you cross the energy barrier, EA, it will not react. So the dissipation is avoided, and storing them is pretty easy. It's liquid and solid. So we can build this energy storage which can last for days together at very dirt cheap prices. It's like at price of a cement or sand used for construction. So this is essentially what we are doing. The benefit is we are using existing technologies, processes. We don't go, there are in, the joke is nuclear fusion is always 40 years from now. So because the technology is so advanced, the problems you have to solve are so huge that it takes time. What we require right now is something that can be deployed today, not 30 years down the line. So when you use existing technology from petrochemical industry, from LNG industry, turbines which have been around for 200 years now, it becomes easy to deploy, and it's very easy for people to understand, the end users. So that is what we build. The customers primarily are grid operators and large renewable plants. So I'll start with the plants, renewable plants, solar, wind. They have something called curtailment which is coming now. So Modi ji's put 100 gigawatts of plants, for example. The point is you cannot turn off baseload powers. The coal plants, the gas plant cannot be turned down. If they've been built for 3000 megawatt, it has to generate 3000 megawatt. So the second the grid has excessive energy, they cannot turn off the coal plant, they'll turn off the solar plant or the wind plants. And this is very apparent from the fact that Suzlon is doing 10,000, it's 10,000 crore in debt, it's not making money. American and German and English grid, they've already seen this where the price is going negative, which is bad for both the renewables and traditional power plants. So those are the first one. Like if there's a Suzlon wind park, we can come in between them and the grid. Whenever there's excess energy being generated, we can store that energy, time shift it when during periods of peak hours. Instead of ramping up your coal plants, we can jump in and give that power to them. So this makes the system very efficient. It removes all the intermittencies. And second is power grid. We are already talking to KPCL and Tata Power in Delhi. So they have the biggest incentives because they are at the end of the day controlling the grid. And if anything happens, their grids fall. So those are our biggest two customer segments. Also, we have large industries like cement, petrochemical industries for their captive generation. We've already talked to a few sugar plants. So the bagasse that they get in the end, they burn so much fuel that they generate more electricity than what they require. So in the end, most sugar plants end up giving electricity to the grid. If we come in, we can increase their efficiency by about 40%, thereby increasing their revenue source. The problem, this is already discussed, the solution. Some of the biggest benefits we give is basically efficiency and storage. So Tesla, one of the biggest questions we get asked often is how do you face companies like Tesla? Elon Musk is one of the smartest guy around. But the problem is lithium ion cannot do time shifting. It cannot store energy for 6 hours. The biggest battery that has been placed in South Australia, I forgot the capacity, it's in gigawatts. It's touted as one of the best achievements of batteries and it's going to help with storage for South Australia. But the fact is it cannot give power for more than 4 minutes. What it does is it adjusts frequency which changes because of wind and solar. Same thing with Tata Power in Delhi. They've bought from Toshiba this year and they present it as energy storage while it's not energy storage. If we fool ourselves, we can't really solve any problem. So that's what we want to do. Revenue model, we basically don't sell engines. We basically sell energy. And therefore we charge people just like utilities for the amount of kilowatt hours they've used. And because our systems are designed for 30 plus years and the cost of building them is really inexpensive. And we don't have OPEX, not much of an OPEX because the cycle is closed loop cycle. We don't burn anything and therefore the OPEX is very negligible. Therefore we can bring down our price of power. We estimate at megawatt scales we can go as low as 25 paise per kilowatt hour. So we've sold about 3 engines so far, up to 100 kilowatt. We are building the fourth one in Devnali, and we are looking forward to a customer who could help us with a megawatt scale pilot right now. And right now we are charging them at very low volume production, 2 rupees per kilowatt hour. Help we seek is primarily funds. We are capital intensive. If we make a megawatt scale plant, the first one's going to cost us about 3 crore per megawatt. Fun fact, most solar and wind today, after so much development, is at about 5 crore per megawatt. So we are already much cheaper than them. Second is potential customers. We are already working with KPCL and Tata Power, but the problem is they require plants in multi-megawatts, 10, 20, 30 megawatts. So they're not so much of a help at this stage. So what we seek is some smaller institutional customers. For example, IIM Bangalore is one. If we could power one of their buildings, that would be a great start for us. It's large enough, probably up to a megawatt, 2 megawatts. You already got 2 large DG sets right next to NSR cell. We could potentially replace those and thereafter move forward. So that is one. We've also thought of, so the problem is not many people require power plants. So what we are trying to do is enable electric vehicle adoption. The BMTC has tried electric buses, so has Delhi government, a lot of them have tried. The problem is they're really expensive. And they are really expensive because the battery pack in them is so freakishly expensive. What if we could reduce that size? So basically what we are thinking is you have interstate buses like Pune to Bombay or Mysore to Bangalore, or even our own airport express. So if you could put a small power plant in between and they could just swap batteries every time they're at say the airport. So you don't need that 200 kilometer range or 400 kilometer range, and therefore you can reduce the battery size, reducing the cost. And since we are giving power at very low cost, it becomes comparable or even better than existing CNG or petrol diesel based buses. So this is primarily the help that we seek.
Thank you. Yeah. Thanks for that. Awesome. So questions? Are people just reeling under the impact, the shock and awe effect? This was amazing, right? Okay. Where have the mics vanished? Oh, all right. You can start.
I didn't get who is your customer. Is it the government sector or?
So it's primarily the government sector, grid operators like KPCL as well.
KPCL or?
So the ones who run the grid. So we want to be an independent power generator.
You mean somebody having a solar power plant or something like that?
Yes, sir. So there are 2 types. One is the ones who have a power plant. For example, Ceslon, they have a lot of wind plants.
Wind power.
So we can give our system to them. It sits in between them and the grid.
Ah, okay.
So we basically bring stability to their output. So that is one customer.
Replacing the battery.
Yes, sir. Replacing the battery. Or the second is the grid operators. So if you have Ceslon directly connected, but if KPCL gets us on the grid, we can do the same thing without being a customer of the solar plants. The grid is interconnected. So you put energy here or there, it's one and the same thing. So if you put a battery here, I'll just put it...
Can I ask you to caricature diagram, say the thermodynamic cycle?
Yeah, definitely.
That underpins your system, right?
This is the generalized diagram.
Pay attention, folks. You will be asked questions at the end of this.
So basically we start with liquid working fluid, just like how you pump in water in typical thermal power plants. We use heat exchangers to heat it up, bringing it to about 400 bar pressure at about 300 degrees Celsius. Typical power plants operate at 60 bars, so we have that pressure advantage. Run it through a turbine to generate electricity. It gets captured by the first catalyst, which is a liquid. The capture ratio is 1:10,000, so effectively creating a sort of vacuum in the turbine outlet, and we store it basically. So that becomes our energy storage. Whenever we require energy, we send it to the reactor, change the pressure, requires a little bit of energy, and it starts desorbing the working fluid and giving out a lot of heat. So we can use that heat again in the heat exchanger or store it or whatever, and just pass through a radiator where we cool it down. At high pressure, it again liquefies here, and then the cycle repeats. When you want the reactor catalysts back.
So the state change that takes place here,
Yes.
right? What kind of a state change? I know there's probably something proprietary going on there, but in layman's terms.
A state change in this, I didn't.
So,
liquid to gas. Basically,
Yeah.
potential kinetic to
So that happens here. So here it's liquid. Here you impart heat to it at high pressure.
here.
So here it's a chemical process. It doesn't change state per se. If you have ammonia, for example, and water, we've done that experiment in school. It gets absorbed. It's not changing phase technically, but it's getting absorbed. So that similar process happens here. In catalyst, when the molecule comes too close to the catalyst molecule, it's like a cage. Once it comes inside, it has a very hard time coming out of it, unless you give it extra energy. So that's not particularly phase change, but
So you create some kind of a potential well.
yes.
Okay.
So that's what we store. That is sort of a potential well.
Awesome. Questions?
Yes.
I'm just talking to somebody who happens to have a 12 megawatts power plant.
Yes. Yes.
For me to understand now, is it a closed loop system?
Yes, sir. Yes, sir. Close loop.
Once you fill in the water,
Yes.
okay. Let's say I'm talking about a steam turbine, and then the process continues.
Yes, sir.
And there is no energy loss.
There are always energy losses, but
That's converted to electricity.
yes, sir.
Okay, so then you need to put so much input excess energy for the because the energy generated is the energy lost.
Yes, sir.
Correct.
So part of energy is always lost no matter what you do. The difference is in typical steam power plants, the biggest one, the most efficient one, there is still a lot of steam loss which happens. There are systems like PRDS and stuff which captures the steam and they try to reuse it, but it doesn't get reused as much because they have mechanical processes.
So he's got a thermal power plant.
Yes, sir.
He's got his own rice flour mill.
Yes.
Okay. So I'm talking about his case.
Yes.
So he's got a thermal power plant. So what is the energy wastage over there?
At least 42%.
42%.
Yes, sir.
Okay. So continue.
Yes, sir. So because they have a condenser, if he's using a water-based cycle, the condenser itself loses about 38 to 40%. And I'm talking the most efficient ones that the KPCL and all they use. So the smaller ones are even more inefficient.
Okay. So okay, I got a point. So basically, it's more like a catalytic converters you have generated.
Sort of, not exactly.
Okay.
Yes.
Okay. Okay. I got a point. And for a 12 megawatts, what will be the cost to get that 40% efficiency?
We right now for ours.
No, somebody's got. I'm talking about this. My friend of mine who's got 12 megawatts plant. He's got.
Yes,
His wastage is 40%.
Yes, sir.
Now to reduce that 40% wastage, what is the kind of capex you're thinking approximate?
He cannot reduce that wastage alone, like with his cycle, because he has to use a condenser, and the condenser inherently loses heat into the atmosphere. You have a cooling tower,
Yes.
so you cannot avoid that. 40% has to go to run the cycle.
Yes.
What we say is we can come in and do that for you.
Exactly. So I'm assuming that he implements your system.
So we'll generally be about 2 to 3 crore per megawatt.
Okay. 2 to 3.
Capex.
Okay. Okay. And he'll recover that in hour of
About 2 to 5 years, depends on utility factor, how often he runs his power plant. It can be as low as 2.5
Because
years.
his case, what's happened is he's generating. What happened that as you said, the rate per unit is not getting it, so his
Yes.
operational cost is high.
Yes.
So now he's using the energy plant only to operate his rice mill,
Yes, sir.
and
Yes.
so he's not stopped supplying to the grid.
Yes,
So
sir.
if this case is coming in, maybe he'll consider.
Definitely. Does he burn husk to generate the power?
No, he initially had a thermoplow and a separate unit.
But what did it burn? The fuel.
I have to think about it. I don't know.
Because if he burns husk, he can always run it 24/7 after we come. He would make profit. We've already done this with, there's a company, Pointec Pens, just outside Bangalore. So he is into energy and he has a power plant in North Karnataka where he burns bamboo shoots and stuff. So he made losses on that.
Because calorific value?
Because of the calorific value and a lot of losses. What we did is we took that energy waste heat and then we generate some extra electricity for him, which kind of breaks even his proposal.
Okay.
So questions, where's the other mic? Right, yeah. You can ask yours and then we'll go to that.
You have a ready case?
Yes, sir.
You have?
Yes.
Okay, so a couple of years back, I read about one article where the problem was time shifting, right, which you're talking about.
Yes.
So what they did was in a, I think, desert area somewhere, I think in Middle East, that they have this solar, array, and then they use molten salt.
Yes.
To do this time shifting.
Yes.
So going by that, I think your system also can come in between. Is that the case?
So that is called CSP, concentrated solar power.
Right.
It doesn't use solar panel, it uses solar reflectors like mirrors.
Right.
The problem is when you melt salts, any salt, they become very reactive. So the metallurgy itself is has to be very complex. And Indians aren't particularly good with metallurgy. Second issue is the temperatures required is 1000 degree plus. So the amount of mirrors you require is huge. So as an example, we also can do solar thermal. With KPCL, there's an island in Bangalore. They want us to power that island. The problem is the mirrors itself made by IIT Bombay is 2 times more expensive than what our engine is. So that becomes a big problem. There are plants which has been tried. One is in Rajasthan. Americans have tried one. Italy has tried one. Spain has tried one. But so far they are a little more expensive than photovoltaics, primarily because of the salt and mirrors.
I mean, I'm talking about the residual energy, right? So residual
Yeah,
energy
so,
can it be used to heat that?
Yes, but you don't want that because also if you look at the time shifting, that doesn't run more than 6 to 8 hours maximum, the best one that I've ever heard of. So it doesn't time shift to that degree, and basically it's so inefficient that a lot of these plants have shifted to natural gas now. So they use natural gas, burn it and use that heat rather than storing energy.
So we'll go there. Can our mic go there, please?
My family business is part of this power plant. Like we do erection and fabrication of the instrumentation electrical part for the boiler companies who do engineering. Like Thermax is one of our main clients.
Right.
Working with them for around 12 years now. I personally have done around 7 boilers.
Oh.
So in this case,
60 bar pressure? 60 bar?
different capacity and different technologies. My last client was Tata Steel, who had West Power Heat, the boiler fired gas, which comes from their steel kilns, and they use it for power generation.
Right.
So what I understand is your system can work with those boilers as well.
Yes.
It's using the same heat.
Yes.
Instead of the steam, this system will be used.
Yeah. So there is two way existing, like Tata Steel, for example, they've invested 100 crore in making those kind of boilers. They don't want to throw that away.
No,
so
but what they do is they have, for every kiln, they have 5 boilers.
right.
So what they do is 4 of their boilers are running at a point and they always renovate one.
Right.
So it's just a ongoing process every time.
Right.
So every 5 years they change that.
Right.
So once you can get into that, you will have your system installed instead of somebody else coming in.
Exactly. So to those customers, we basically promote 2 ideas. A, you can continue using your boilers because they also lose a lot of heat. So we can capture that heat, the loss that you're having, and give you some extra energy. But that won't be as efficient. If you remove your boiler completely and we come in, so we can give you a much better efficiency boost.
So in that, how would you use the boiler fired gas or waste heat and everything? Waste
So-
heat, I can understand you can use.
Yeah.
What about the other gases that they use for production?
So we can basically extract heat as long as there is no chemical reaction happening,
Okay.
where they want to cool the gas stream. So we can always use our heat exchanger. We can bring a fluid temperature, any flue gas temperature, right to minus 60 degrees in effect. We don't do that because no one wants minus 60 degree gas, but theoretically we can do that.
So your heat exchanger can fit any kind of mechanical configuration? Because all these flue pipes are just done, I think, quite haphazardly, right?
Right.
Each plant is different.
So yeah, mostly it's not a very complicated thing. Only thing we ask is it should not react because that disturbs our heat exchangers.
You have any IPs around it?
So yes, sir, we have a lot of IPs actually, but two problems. One, they're really expensive to file patents. Second, if we file patents, companies like Alstom and GE, they can always go around it. So right now we are going with trade secrets primarily.
So I can help you to reach out to institutions.
Yes.
No? Educational, research,
Yes.
Colleges, universities.
Yeah, can we make sure the mics get to the people? Because otherwise you're not going to get a recording.
Can I ask?
So why you're targeting only grid companies and not the power generators who actually are doing that work?
Because power generator, they already have their setup. We did talk to KPCL, for example. They sent us to Raichur, the thermal power plant. And
KPCL full form, the
Karnataka Power Corporation Limited. So they are power generators. And they typically are not allowed to buy electricity from someone else. And still they were interested. But the problem is the best efficiency, why they would want to pursue us. The prerequisite is remove your condensers, which they would not do at this stage, unless they're building a new power plant. The other way is condenser exhaust that you have. So you've got about, for a 210 megawatt power plant, you'll have about 2 to 3 megawatt of energy still remaining in the condensate, which is coming, and you can use that. So that was our idea, but the problem is the condensate is at about 40 degrees, and they want the condensate at 30 degrees after that, because the boiler have to work hard again. So that is a very difficult task to do. We can do it, but it's not worth the trouble.
Questions? Can we make sure the mic comes? We'll come here. There's another mic here which you can use. Take anyone, yeah.
So the thing is regarding the IP part, since you said it's too expensive, I know an IP lawyer who's highly startup friendly.
Okay.
And he files my IPs and all you need to do is just pay the actual filing costs, which are like hardly like about 10,000 rupees or something like that. And then after that, his charges are extremely reasonable.
Okay.
So I can connect you to that. And also for the legal and CA part,
Right.
I know actually 2 of my CA friends who are also highly startup friendly.
Okay.
So I can connect you.
CA definitely we would love to, because one area where we really suck is regulations. But IP, the second issue we have is we don't want to file an IP just yet, because IP is a public document. So
The big global corporations will come and
They will find a way to
beat him around it, and then somehow undo the IP.
But that anyway going to be the case.
But it's a qualified for IP.
it's not going to be just yet. So until we have the cash flow to sort of protect our IP, if I do a patent right now, within 2 years it'll be public. So companies like G.
No.
Okay.
It doesn't
For
work.
20 years.
Public will happen.
guys, can we?
Okay, just 1 minute. I'll tell our experience.
One person at a time.
I'll just tell our experience. First, you file for the IP patent, right? Then you have 1 year. After that, you ask for examination,
Yes.
and you can delay that.
Okay.
So when you ask for an examination, then only they'll start examining that, and after that, it take 1.5 years to get it published. So,
Okay.
so you can delay it to an extent where you file now, you are protected, but then it can go up to 2.5 years for it to be published. Actually, not 15 months or something.
But after 2.5, it becomes public, right?
Yes,
So that.
it becomes public property, as in not exactly it is published, but then people can go around it. But then it's up to you how to make it.
How strongly file it?
How
So sir, that's the big problem.
you file a family of patents. Actually, you keep
Yeah,
filing one
exactly.
after that.
So
it's
we.
worth talking to him. I think Dilip, you've done it, right? Okay.
So the problem is if it becomes public in 2 years, for example, or say 4 years, companies like GE, which have $1 billion of funding, they can always reverse engineer some of our key components like catalysts. I don't have GCs which cost like 3-4 lakhs. They do, and reverse engineering catalyst, for example, is not the biggest challenge for Dow Chemicals or GE or one of those.
They can do it right now also.
Exactly. So as of now, when they don't know what I'm doing, it's much easier for me to sort. If they do it right now, they can probably get patents. Agreed. But so far they haven't done it, and they're not into those kind of areas.
See, I know one person who has worked about 40 years in the IP, patents and other things. If you want to talk to him or something, I can connect you.
Yeah.
So the first part what he was mentioning as for first year, so that is actually the provisional filing where
Right.
you don't need to disclose the details.
Right.
You can just have it very abstract
True.
with which nobody can actually sort of gain your trade secret.
True. But that what I'm saying is that 1, 2, 3, 4 years is not really enough for us to reach that position where we can compete with GE. If Apple sues us, we can't really fight back, or we can't sue Apple, for example. So that is our biggest issue. Unless we ourselves are a billion-dollar company, doesn't make sense right now. Once we exactly. So, but the thing is, why we don't sell engines. Also, the second reason is this: so we can maintain our IP. We don't sell to KPCL. We are operating for them. We are just selling them electricity. So when no one comes in our system, there's very little scope for them to figure it out.
We'll have to get into suggestions. We'll start with you. We already have, but we'll start with you.
So one thing I just wanted to ask you whether you want to be a tech company or a service company. So that makes you a difference. For example, if you want to be a tech company, you need to have an IP.
Right.
And prior to that, you had to be very clear, are there any prior arts?
Right.
So once you are clear that your IP is novel, I would suggest you to file a provisional patent.
Right.
So that will give you 1 year of time period.
Right.
Suppose that you can file the complete specification. It depends on you how you are making those claims.
True.
And you need to have a smart guy who can actually draft a claims for you,
Right.
where you can play around with multiple patents as he suggested. But again, to get a patent grant, so it's up to you when you wanted to take it. And normally the granting of the patent will take between 6 to 7 years. And there are some cases where it took like 13, 14 years. And the patent period is like 20 years.
Yeah. Okay.
So I would suggest if you are strongly about tech company, you should go for an IP.
Definitely, we'll look into it. The only cause for us is the period when it becomes public.
Yeah, and one more thing.
Is there anything that you can help him with regards to funding from DST?
Yes, and interestingly, many governments does a reimbursement on IP. For example, if you are incorporated in Karnataka, 90% of your IP will get reimbursed. Okay. And apart from that, if you have a smart consultant, you can file IP on your own. Okay. For example, it is just to file a provisional patent. If you are going for any consultancy firm, they take between 30,000 to 80,000. And if you are doing it by yourself, you can, if for example, like we have 4 offices. So for us, it is in the South region, that is in Chennai. Okay. You have to just file for provisional patent, that is $1,700.
Okay.
You can just see the difference, but it depends on you how you are drafting and how you are making claims. Right. But as you suggested, we need some startup-friendly person who can help us.
He's good at writing grants, so I think for DST grants, to talk to him, see if you can help him out. Yep.
Yeah, definitely.
So you may have already answered, but if your tech is implemented in a company or sector, is it not easy to just dissect the tech behind it? Like if you're concerned about your patent being, people working around it. But if you make an installation, can a company just not evaluate, study, observe, and then just? Yes.
Yes, sure. They will reverse engineer.
What would it take to reverse engineer this whole thing?
Yeah, it takes a lot actually. For example, BHEL, we are pretty sure cannot. The kind of capabilities required is enormous. GE is someone we are really scared of. Alstom, Siemens. They are the ones who have the sort of intellectual capability to actually go around, because you've got multiple IPs in this, not just a single one. So that is one. Second is...
So this is what's really novel, right? Or are you saying this is also very novel?
So the liquid itself is very... there's
the
IP
principle
in that.
is not, but the liquid is.
Yeah, exactly. So we haven't changed the cycle that much, except for you have a lot of mechanical processes here. We've replaced all of that with chemicals. So this is one. And the second one is the liquid. So...
I'm guessing they would somehow sort of reverse engineer this, but this they may not, right?
Exactly. In fact, GE, Siemens, they're better than us in this thing. Like heat exchanger, we might end up buying from them. So that is okay. So they're really good with mechanicals primarily. This cycle is completely new, and that's why we have an advantage over them. If we were doing something 20% better over Rankine cycle, we're pretty sure they'll just reverse engineer everything.
I can connect you to SAFE, which is a VC firm.
Yes.
They've invested in a lot of, say, core energy tech companies, core mech tech as well. So
that'd be great.
Yeah.
So in terms of connect, I don't know if it contradicts the business. I know a few manufacturers up north. They are like large scale manufacturers, but they manufacture transformers. I don't know if your solution contradicts their business scope, but they do have a large government supply.
It's completely different.
It's different
segment.
than it's yeah. Okay.
Yeah, her hand's been going up a while. Sorry about that.
Vijay, I think for me personally, this has been one of the best that I've heard for the last 10 sessions that I've attended. The reason that I say this is I work for the United Nations, so I think you're playing it too small. This year, we were supposed to be having our education summit that's supposed to be happening in the month of November. They haven't still finalized it because climate change is something that the United Nations is looking at very, very important on that scale, right? So if you can help me, because I work in the education sector, so I still head the Global Youth Alliance, but I don't understand the nitty-gritties of it. So if you can put this together in a way that I can take it to the next set of people, I will give you the platform. Thereafter is all yours. So we have 117 countries on board. So I'll help you out to pitch to those 117 countries. Thereafter it's yours.
That would be
So give me a socially relatable pitch story. That, I like the way you started. I think I got sold the way you started. So if you can give me a socially relatable slides, and if you can put that presentation together, I will also have my committee members talking to you, and thereafter we'll take it forward from there. That's what I can help you out with.
That'd be really great. You want technical
No, I wouldn't want the technical specifications. I would want you to tell me saying what's happening across the globe, and how will this make a difference from the small level to the biggest. What's the impact that's going to happen, and why should the nations look at this as a solution? Thanks.
Did you think he set the context well? Exceedingly well, right?
Yes. He's one of the best speakers I've heard.
Awesome.
Because you see, if you are not from that background and you're able to still grasp what he said.
Yeah, he got us all in a state of hypnosis in 2 minutes.
Yes, absolutely.
So one of the things.
28.
Okay,
Wow.
see, there's another thing that's happening called as the Global Youth Forum, which is happening in Egypt. It's happening in December. The registrations are open for anybody working in anything which is making a change to the SDGs. You can put this under affordable and clean energy and register yourself. I do know somebody who's the organizer there. I will also try pushing it, but you can't push it as just an entrepreneur. You have to push it with the right intent, and that is a very good platform as well, because the president of Egypt is going to be there, and a lot of good people will be there. Hopefully, G and all might still walk into the store, but yeah, it's still nice to have. Yeah.
It gives me an idea. I used to know someone who used to work, say in the advisory office for companies set up by students of MIT in Boston, right? So we'll see if you can be shortlisted for MIT's 30 under 30 or something like that. That will be unless you're already on that list.
No, not yet.
Okay.
I graduated from MIT, so but never really got into that.
Okay.
We were really bad with marketing, social media, all of those. So.
No, I think you should be either on MIT's 30 under 30 or Forbes 30 under 30. That just sort of catapults reach.
And this is your year. I think a lot of things happening in climate change, and everybody's trying to attend, so you should take out as much as you can.
Awesome.
Donald Trump.
No, Donald Trump.
So one point. So on the advisors part, I can actually connect you to one company called Amber Root. One of my very good friends is there, and he's been in that for the last almost more than 11, 12 years.
Okay. Yes.
Okay, and then this Amber Root is into energy.
Okay.
So he would understand the business.
Where are they based out of?
Bangalore.
Bangalore. Okay. That'd be great.
Yeah.
Just a moot question. Would someone like Gautam Adani be interested in him? Should be, right? Not exactly, is it? Okay.
It has to go to the decision makers who are working in that particular sector. Gautam Adani is handling
everything.
The whole of the company. He doesn't look at every process that is going on in the company. If he goes to probably Adani Power's head, he will be a better person to talk to than Gautam Adani.
I know the current MD of Adani. He used to be the ex-MD of a Tata company, and he was my super boss at one time.
Please connect him up.
If you want, I can put him on to you. But you definitely run some kind of risk of an disintermediation when you deal with such companies early. If you are absolutely, and I was listening to you, you have to be very, very careful in terms of what you are saying, how much you are saying, and how much transparent you want to be.
Yes.
Because this fear of this is, mind blowing. I have attended many sessions, but it took me 15 seconds to get my bearings back to hear you cogently. So I can put you on to him, but like she said, you'll have to create a social pitch because these are hungry corporates.
Yes.
And you have to guard your turf and be always looking behind your back. If you're confident of that, I can set a meeting with him in the next 5 days if you want. He's on first name basis with me. I can do that. No worries.
Yes.
Okay. All right.
I also can put you on to top 10% in Reliance.
Okay. Yes.
But again, yeah, so even I can get you in touch with some if I don't want to, because there is a company called Carbon March in Bangalore itself.
Yes, we work with them.
See, I think that's a minefield that SAFE's actually really helped, say a lot of IIT Madras companies maneuver.
Okay.
Because it's a company called Detect. They make NDT based corrosion detection devices.
Yes.
You can clamp them onto pipes.
Yes.
They're huge into oil and gas. So SAFE really helped them navigate
Right.
GE, because GE was coming after them almost every month saying, we'll put in the money,
Right.
Right? But they didn't want GE because it would have locked them down globally.
Right.
They wouldn't be able to sell to a Thermax, for instance.
Exactly.
Right? So I guess you want to stay value neutral, right? That way.
Right. Exactly.
Okay. All right. We've got 10 more minutes, guys.
Skilled team, is that getting engineers with the requisite skill set? We have too much of engineers.
We have too much of IT engineers. And in mechanical, for example, I recruited initially from IIT Bombay. A lot of people, they don't know application of MATLAB for very complicated situations like getting data analysis. As an example, so when we made the turbine, it fluctuates. So it's moving at a RPM of 1 lakh something per minute, sorry. And if it touches the casing, it instantly shreds. It doesn't break, it shreds. So you need to have a very strong control system with the loop control system to make sure it doesn't happen. And we expected IIT Bombay, like AIR 50 something, to be able to do that. But the first question they ask is, we weren't taught this. Could you teach it to us? So we don't want to get into the teaching business just yet. So that is one big problem. Second, experience. So we almost recruited 2 engineers from Rolls-Royce. They were sent to England for 2 years to learn by Rolls-Royce. The first question we asked, can you build a turbine for us? They were like, no, we cannot. It needs crores of rupees. We don't have the expertise. So that kind of
So you need a lot of can-do,
exactly.
self-taught,
right.
highly motivated,
exactly.
plus skilled engineers, right?
We're not looking for engineers with who have 30 years experience at Rolls-Royce or Trent engine, but someone who's interested to actually try building one. So, but that is very rare here.
See, Detect solved a lot of these problems. Can I connect you to the IIT Madras ecosystem? Are you incubated somewhere, or
we were incubated at NASA in ISASIL and Tata Trust.
Okay.
But now we are on
you're
our
open
own.
to? Okay, so I'll connect you up.
Yes.
Would you be interested in somebody who designs turbines for somebody like Suzlon?
We would love, but Suzlon, wind turbines or the?
Currently they're doing wind turbines, but the guy I know is somebody who's a chemical engineer, and he has a couple of other mechanical engineers.
Right.
They're based here in Bangalore. It's a company called Karnataka Engineering Works.
Okay.
So
I'd love that, but wind turbines are way different from sort of gas turbine. They rotate at say 10 RPM. Ours
It's
goes
10,000, right?
1 lakh plus.
Okay.
I mean, what's the maximum RPM of an IC engine, just for reference?
IC engines goes about 1,000. How much?
Formula one will go up to about 18,000 to 20,000.
Yeah.
Tata Trust and Group both. So Tata Group, TPDDL, Tata Power Delhi Distribution. So their CEO and CEO both are sort of, we were working with them.
That is one of the power companies. company
Yes.
in the 103 companies.
Yes.
The group, which is Tata Sons,
Yes, sir.
Bombay House,
Yes.
and the Tata Group is actually structurally involved in a lot of nation building activities.
Yes, sir.
They are very different from the for-profit
Right.
Reliance and Adani Group.
Yes, sir.
So even if you want to go and make a presentation in Bombay House to the chairman,
Yes, sir.
or even to Mr. Ratan Tata, who's the chairman emeritus,
Yes.
it takes some time, but I can put you on.
That would
They
be
will
great.
actually look at this as a nation-building cause and coming something from India.
Yes, sir.
Vis-a-vis those, and they will not disintermediate you.
Yes, sir. That would be the best.
Tata Trust actually puts more than 1,000 to 1,500 crores every year into these kind of causes.
Yes. We would love if.
The Tata Group or Tata Trust, they're very different from Tata Power, which is a very small company.
Right.
In the 103 company group. If you want, that can also be arranged.
That would be the best.
So you need to talk to him. I'll connect you to Saif. You need to
Yes.
talk to her.
Yes.
What are the other leads that came up for DST? IP. You also mentioned IP lawyer. So I think he's not going to be able to remember everything, or can you? Let's reach out to him. Yeah. Is everybody on his support group? Yeah. All right. Okay. Those who really need to be there. Please.
deMITasse.
Is the link to his group listed?
I can put you connected to 200 placement officers who are currently there. Okay, so you put it together.
Yes.
You say, I want somebody to fill this up and then send it back to you.
Right.
And then you can filter it and then take it forward. If you want, I can help you with that.
Definitely.
Please do. Please do.
Yeah, I think I can put you on to someone in the Middle East, very close to me, who's been in the heat exchange business for the last 40 years, and currently a CEO of the company. I don't know what will come out of it, but it's a connect, and you can kind of take it from there.
In fact, if he's been there for so long, if he can help us get to Middle East, that would also be very helpful, because that is one of the best markets. They have a lot of money. They've been building a lot of solar photovoltaic this thing. They might be open to something like ours where we use solar thermal, and it's a very hot country, so that might work.
Yeah, so you'll have to explore, but I can get you on.
One of the best startup programs.
Exactly, yes.
I mean, you will even get funding from them,
Yes.
right, to set up shop. So that will be a great connect. I hope you can remember all the leads generated.
So he happens to be my brother-in-law, so
That'll be
easy
because
to
we
get.
have. I personally know no one in Middle East. Otherwise, I would have tried. Yes, sir. No, yes, sir. I didn't say I don't want to do it. What
But I don't
said
think
is,
he was aware of the tactics that they
Yes.
suggested. So
we are always open to it. But the thing is, in tech, you can always re-engineer. We are sure once we are out there, someone is going to re-engineer it at some point. We just want that point to be at the point when we ourselves are a big company. Yeah, that is a risk. True. Yes, sir. That I agree. Yes, sir. Yes, we are always open to that. As also, like, if the price is a little low, it becomes if we've got about 20 patents that we would want to file, not the family, just the core patent. That climbs, the price climbs very high. Plus, you need to cover the. Does it refund for foreign patents also in the
Yes,
US?
for PCTs, you will get. Yeah.
Okay.
can we get the mic to him, because I think his inputs were never recorded. Yeah.
Yeah, NASSCOM has a tie-up where they have a NASSCOM certified legal patents.
Right.
So you can talk to them. I think it will go with peanuts.
Okay. Definitely.
But please
do
protect.
they help non-NASSCOM funded companies also, or
Yes, anybody.
Can you connect him by any
Yes,
chance?
I will.
Yeah.
Part of the Make in India initiative.
Yes.
They reimburse.
Okay. You need to be a recognized startup.
You are already incubated IIM Bangalore.
Yes, sir.
That's enough.
Okay.
I don't think even you have to pay. I think somehow they get it directly money from government.
Okay.
I can also tell recently,
Yes.
Government of India, Nirmala Sitharaman has CSR funds for R&D.
Yeah. Yes. Excellent point. I think then
Any big company can fund you. That is free money for you.
I think the Tata Trust angle is a brilliant angle that way, right?
And they will be very much interested in something like this.
Yes.
But you have to socially pitch it.
Yes, sir.
You know, it must come out very clearly that this is something which is strategically social and nation building.
Yes.
Because they put a lot of onus on nation building and, you know, philanthropic
Yes, sir.
kind of a thing there. And money is never a concern for them.
Yes, sir. This has a lot of social impact. We just don't pitch it because no one really cares about it often. But the thing is, if you can make a microgrid, today they'll put a solar panel and they'll give power only for a phone recharge, a fan, a light, that's it. The point is when demographic, the economic status of the overall demography changes, they would require fridges and all sorts of stuff. The microgrid cannot help at that point. So we can always come there and give them electricity and act as a battery source for the grid. So we'll take energy from the grid and whenever they require, we can just give it back. So.
I have one more small doubt. Somebody's got a solar power plant.
Mics up, please.
This also can help in energy.
Yes, sir. If you have a photovoltaic power plant, all we do is we use resistors. We convert that electricity into heat and we store that heat in our systems. So
Can it be can you make a micro version of this for a home?
we've done that, but it's not the best of ideas. The turbine gets very expensive. It's much easier to use a battery at that point. The precision engineering is complicated.
So wherever there is waste heat, I think.
One more question.
Yes.
Can this be used in, let's say, because a lot of our plants use boilers.
Yes, sir.
Okay, and so, for example, laundry industry, they use
Yes.
boilers. So there is a lot of energy wastage over there.
Yes, sir.
So when the steam is generated after that,
Yes.
steam being wasted.
Yes.
Can this be applied there also?
Yes, sir. It works perfectly in those kind of situations.
Even for a 1-ton boiler?
Even for 1-ton boiler, and more importantly, usually the current system, waste heat recovery system, they work only above 100 degree, 200 degrees Celsius.
So there is I don't know how you're going to address this problem. Yes. There's a problem especially in the washing industry and in the laundry industry
Okay.
That's why I shut down my commercial laundry completely.
Okay.
I used to buy briquettes.
Yes.
Okay, which had very good calorific value, and
Right.
I was paying around 4,000 rupees per ton.
Yes.
Okay, and the cost was increasing, and the calorific conversion I looked at it, for me it does not make sense to use briquettes, so I shifted to tamarind trees.
Yes, sir.
Which have made me feel guilty of the fact that indirectly I'm buying the same, because the high calorie you have the roots of the tamarind tree.
Yes.
So since I'm more concerned about nature and everything, I forced myself. I completely shut down because the energy cost was huge, and I realized that 50% of the energy was getting wasted.
Yes.
Okay. So there, if you can build up a case study there and say that if you can come out solve that particular problem, I see a huge potential in those industries, because you use in sugar industry there is boilers,
right?
Laundry industries, washing units, denim washing units, so boilers used. So if you can meet one of the boiler inspectors,
right?
Then industrial safety and boiler inspectors are there down Banarkata Road itself.
Okay.
You go meet them, he'll give you the list of all the people who have got more than 1-ton boilers. 2,000 rupees.
Yes.
On that note,
Actually, as an exception, HOG should actually form a very lively collaboration.
I think it's the first time we've seen so much feedback, say flow in one direction.
The idea is good. People get excited.
Its potential is great.
It's huge.
Number one, and impact will be
huge. Yes, sir.
And he's very small. He's worried about even filing the patent. People will come. If all the people here, we form a very.
Yep.
Go bash up everybody.
Yes, sir.
See, when we talk of solar, we talk of really green energy.
Right.
But I am not sure whether it is really green or semi-green.
Yes.
Because even the manufacturing that photovoltaic cell and the storage, if you take the whole end-to-end chain, whole supply chain, If you take the total, I am really not sure.
See,
Somewhere we are trying to push on one side,
Can anyone get him a meeting with Amitabh Kant of Niti Aayog for him to just present the idea even in lay terms?
Mukta said she knew somebody.
You should talk to Mukta, right? Because they have grants from Niti Aayog. They're very accessible. I know. You can do it? Awesome.
Yeah, even
awesome.
I can do it through C campaign.
Please do. I think if we get him a meeting with Amitabh Kant, he can, I think, open all the government doors. So government doors, Amitabh Kant, Tara Trust, you've got SAFE, and then you've got UNICEF, and then you've got the lawyer there, CA also, and then you got DST. Right.
And one more thing interesting, he's asking about funds. Can you just let us know what kind of funds you are looking for? This is a kind of a hotcake for government in terms of a grants.
Right. So right now, speaking small, we require a fund for our first megawatt class plant, which would be about 5 to 6 crores. But if we go to a VC or an angel investor, typically we want a runway of 2 years. So about 10 crores or something. That's our funding requirement right now. We've been bootstrapped.
Okay.
Vijay, we're looking at 200 crores. Like what do we see? No, I think what we should do, next meeting again, let him come.
Okay.
In between,
let's all work on it, right?
Let us just work together. What all can be done, what it is worth, and all that. That would be really good.
Awesome. So I think your support group's going to go berserk. On that note, we'll have to call it quits, but this was just awesome.